All right, so can you guys hear me okay? Yep, so I guess I'm gonna start by giving thanks to Kana and all content reviewers and all conference staffs for letting me join this conference as a speaker. So Code Blue started in 2013, and I have never had an opportunity to join this conference because around that time I moved to Canada, so it's pretty far away. But even I was in Canada, I kind of kept hearing positive comments about this conference, and I kind of started to think that I wanted to join this conference as a speaker because being a speaker is nicer, right? So I'm pretty excited to be joining this conference as a speaker this year. And also, special thanks to Kentaro, one of the organizers, who fixing my laptop. So there was a small technical issue on my laptop yesterday, but he was like, sure, okay. And he fixed my laptop very quickly. So thanks to him. Thank you very much. And also, of course, thank you for coming to my talk. So I'm going to be speaking about PowerShell for the next hour, and hoping that it's going to be somewhat interesting and useful to your job, applicable to your job, and maybe I can give some new inspiration for your research kind of work. So let me briefly introduce myself. So I am Satoshi Tanda, working at CrowdStrike as an engineer. So CrowdStrike is a US-based company, and there are awesome engineers in the team, and my team is especially awesome. So if you are interested in, please talk to me. Maybe there might be nice opportunities. And I see myself as a low-level software engineer. So I was working as a vulnerability researcher or malware analyst professionally. And I also worked as a software developer and still developing Windows-based security software. And I love to do code at my spare time. So I developed a couple of hypervisor projects on the GitHub. So if you are interested in hypervisor things, please check it out. And also, I love to give a talk at the conference, like doing research and sharing my findings at conferences. So I spoke at Recon and Blue Hat and Alcon recently. And all slides and some sample code I'm going to use in this session is already available on that GitHub URL. So if you're interested in the internals of the sample code I'm going to use in this session, please check out the GitHub website, GitHub page. So this talk is connected to my professional background. So around 2015, I was working as a malware analyst at the AV company. And around that time, I kind of learned that many malware often comes from a small component named downloader. So first downloader gets downloaded into your system, and then that small piece of file, malware, downloads actual malicious file, which is called payload. And around that time, payload and both payload and downloader were executable PE files. So in this slide of the chart kind of shows that popularity of one particular malware family, which is used as a downloader. So that is Upatore, and that chart is taken from Google Trend. So it's kind of showing how often that Upatore was searched on Google. And you can kind of clearly tell the trend. It was at some point popular, but that popularity decreased. And what happened around that time was appearance of like JS downloader, script-based downloader. So you can kind of clearly tell the transition from executable-based downloader from JavaScript-based downloader. And that transition was pretty drastic, I mean fast. So it was also quite frustrating moment as a malware analyst because writing effective detection against script-based malware was actually more challenging than writing detection against executable file malware. I'm going to explain a little bit more about why it is harder, but that was what I felt. And I kind of started to look into technologies or like research around gaining more visibility or having better protection against script-based malware. And that's how this research kind of started. And while I'm studying initial research, I started to notice that there are like appearance of PowerShell-based post-exploitation frameworks. And I noticed that PowerShell was used in wider context compared with JavaScript or VB script or Office macro. So PowerShell could be used as a downloader, could be used to bootstrap, like start up actual payload file, could be used by penetration testers or real attackers for lateral movement by using that kind of framework, PowerShell-based framework. So after I learned those framework, I kind of decided to focus on PowerShell. And this talk is going to be about what I have learned and what I noticed while I'm doing that research about PowerShell. And this talk is going to be about how to gain visibility into PowerShell activities. So I'm going to explain the current threat landscape related to PowerShell and what kind of technologies available and what the disadvantage, limitations of the existing technology, and then going to talk about .NET native code hooking technique in order to overcome the limitation of the existing technology. So my talk is made up of 4 major sections. First, I'm going to explain where we are, so what kind of tools like threat exist, and what kind of protection mechanism exists. And then I'm going to introduce the .NET native code hooking technique in order to overcome limitation of AMSI, which I'm going to explain shortly. And then I am going to explain how to use that technology for actual benefit to get visibility into PowerShell. And lastly, I am going to make a conclusion and give some recommendation. So the PowerShell attacks, PowerShell is used in attack chain very commonly at some point, maybe by a downloader, maybe by an attacker for lateral movement. And it is quite hard to detect by traditional antivirus software. There are many reasons, but I picked a few major reasons I personally felt. So the first one is that executable file of PowerShell is a legitimate Microsoft signed binary. So PowerShell.exe, that is clean file. So you definitely cannot write detection based on a PE file, executable file. So you have to look into either behavior or a script file to detect bad PowerShell activities. But a script file is also hard to detect because it can easily be modified. So you can kind of put big comment section at the beginning of script file, or maybe you can change variable names or swap if block or switch blocks. You can do that kind of modification very easily. And that breaks often breaks antivirus vendors' detection. And even worse, script file may not be used. So PowerShell is a shell. It's not a script interpreter. So you can do whatever you want without using a script file by just using command line or interactively typing commands. So script file might not be used sometimes, actually often in real world. And at the last but not least, like the last one, so PowerShell engine, PowerShell language is implemented in a DLL file. So that DLL file, PowerShell engine, can be injected into arbitrary processes, for example, explorer.exe. And then you can execute malicious PowerShell command or script from explorer.exe. And that makes producing effective detection more difficult because you might want to apply special logic for PowerShell.exe because it is a primary executable file which runs PowerShell. But in fact, PowerShell language engine can be injected and executed in different processes. So you kind of don't know where the enemy is. So that definitely makes writing effective detection more difficult. So I put three examples in a slide. So the first one is basically executing a PowerShell file. You might think this is easy to detect because there is a file. But some antivirus software does not scan a text file because it could kill a system performance. So if the antivirus software does not scan the text file in this case, it's pretty much you don't know what commands are executed actually. And the second example, it's taking a command and executing the infamous invoke expression commandlet, so IXE. And what it does in this command line is it downloads a string from that URL and saves that string onto memory and gives it to the invoke expression command. And the invoke expression command passes that string and executes that string as a PowerShell command. So you do not know what kind of string is going to be downloaded and executed. And the last one is kind of funny because for some reasons, PowerShell takes base64 encoded string. So that is some command encoded base64 encoded command. And if you want to cover this pattern as well, you have to write two patterns of detection for one thing. One is in plain text. One is for base64 encoded text. So it makes writing detection more difficult. So in response to that difficult situation, Microsoft has released a feature named AMSI for Windows 10. So the way that works is in this chart, red boxes are your software. So you write a software and registers that software as an AMSI provider. And once it is registered, script engines will forward script or command before it executes to your AMSI provider. So your AMSI provider will see what kind of string or command are going to be executed, and then you can decide whether that should be blocked or not. So that's pretty powerful because it gives visibility into content of a script file. So if script file is executed, you see the content of the file. And you see what kind of string is passed to the invoke expression command. And also AMSI gives you decoded version of string when base64 encoded string is passed to PowerShell.exe. And one of the nicest things of AMSI is that it gets activated whenever PowerShell or script engine is executed. So as I said, PowerShell engine could be executed inside, for example, Explorer.exe. But if AMSI is available, your AMSI provider gets activated. And even if the script PowerShell is executed from Explorer.exe, your AMSI provider sees script and commands being executed by Explorer.exe. So that's pretty nice. But of course, it comes with some limitations. So we are living the real world. So AMSI is available on
AMSI というのは Windows 10のみで有効です。
8.1 systems are not covered by AMSI at all. And even if you are using Windows 10, if the system has PowerShell version 2, it's not covered by AMSI. So attacker could use PowerShell version 2 in order to bypass AMSI. And also, AMSI does not do storing deobfuscation as much as you might wish. So if you write naive regular expression, it can easily be bypassed. And funny thing also, AMSI can easily be disabled by PowerShell. So if assume you use AMSI provider, attacker got access to your PowerShell session. And if an attacker executes a special command, then that disables the AMSI. So you see the special command, but if you do not block that special command, you won't see anything further. So that's kind of suck. And also there's an unfixed flaw, which still Microsoft is fixing. So AMSI provider do not receive correct data in order to detect maliciousness. So to quickly wrap up the background, so PowerShell is pretty widely used in many ways, and it is really hard to detect. And AMSI has released, and it was a really good improvement. It provides significantly better visibility, but it comes with the limitation. So the motivation of this research is, can we do anything better? Can we have anything better tools? And of course, the answer is yes. So here kind of question, what antivirus security software vendor have been doing when Microsoft does not provide necessary interface, necessary APIs to do what software vendors want to do? Any ideas? So what security vendors have been doing is hooking. So hooking functions. So security vendors have been modifying, installing functions probably for 20 years. So applying the same idea against PowerShell. So I'm going to introduce the .NET native code hooking technique. So this technique is to inspect, to monitor a behavior of manager program by overwriting native assembly code at the runtime. So this technique was not something I invented. So this technique was introduced around 2010 to 12 by Topher, Timden, and Ryan Allen. And this technique has recently been reviewed by Amanda Rousel about its strength compared with similar .NET hooking technique. And we discovered that this technique is superior to other similar hooking technique for PowerShell, well, .NET programs. So let me review the basics of PowerShell, manager programs. So the red box at the top of this chart is C# program, C# source code, And C# source code gets compiled by a compiler, and compiler generates an executable file, .exe file. And that executable file is made up of MSIL. It's not made up of native assembly code. And then that MSIL file, executable file, gets translated, compiled into native code at the runtime or when somebody executed a tool named ngen. So the important thing to learn from here is that even it's a manager program, .NET program, the thing being executed by a processor is a native code, native assembly code. And this is kind of comparison between execution environment of unmanaged programs, like C++ programs, and manager programs. So on the right side, So when unmanaged program is executed, it interacts with Win32 layer. On the other hand, if manager program is executed, it interacts with .NET framework layer. Usually it does not talk with Win32 API layer directly. So the idea of technique I'm going to explain is to install hooks onto either .NET framework layer or the manager program itself in order to monitor how those functions or methods are executed. So let me quickly review how the normal API hooking, like native code hooking, against C++ unmanaged program will work. So first thing you're going to do is you somehow run your code inside the target process. That's step one. And then that code will locate the address of the function you want to install hook, you want to monitor. And then you overwrite the assembly code of the address to replace with your own instrumentation code. And in case of native code, .NET native code hooking, it is pretty much the same, except that we are targeting .NET assemblies and method. So let me discuss those differences a little bit. So the first thing is how to locate the address of native code compiled by .NET compiler, JIT compiler. So to do this, we are going to use a technology called reflection. This is basically a .NET Framework API. So using this reflection, you can get the access to metadata of method or classes or class fields, that kind of thing at runtime. So you can think of this as a full source code access at the runtime against the program. And by using reflection, you get metadata of a method you want to install a hook, and then you call the get function pointer method with this metadata. So that method returns the address of compiled native assembly code, if that is compiled already. And in case if it's not already compiled, there is no native assembly code on the memory. So in that case, you can call the other method named prepare method, which triggers JIT, just-in-time compilation against method you gave to this method. So this is kind of like flow of how you do those things, like doing reflection, getting metadata, and triggering JIT, and get function pointer, and overwrite the assembly code. And the other thing to highlight is that you have to be able to execute your own code to start like doing reflection, like doing get function pointer method. You have to run your code to do those things. So how you can do this? You can do it mostly in two ways. There are two options. So the first one is using the hosting API. So hosting API kind of allows you to interact with .NET Framework world from C++ side. So by using the hosting API, you can inject your .NET C# assembly into the process. So this chart, this blue box shows process address space, and red boxes are your code. So in the middle, there is a bootstrap code. And that's your C++ code somehow injected into the target process, for example, PowerShell. And then that bootstrap code will use the hosting API and kind of inject your .NET hooking assembly into .NET world. And then your hooking assembly do reflection and get function pointer or trigger JIT compilation and overwrite native assembly code in order to install hook. And you can install the bootstrap code in many ways. Maybe you could use a driver, or maybe you could use app init DLL settings to inject your DLL. So this is one way. But the other way is using the app domain manager class. I would recommend this way because this is a lighter, like easier way to implement, play with this technique. So the app domain manager is a special .NET class which you can register as you can write a custom app domain manager class and register that class as a app domain manager by environment variable. And once it is registered, that registered app domain manager class, custom app domain manager class, gets loaded by .NET Framework before manager program is initialized. So you will be able to execute your own code before the target process starts running. So in this chart, there's only one red box. So you just write one single C# assembly code and register that assembly as a custom app domain manager. And when like PowerShell.existed, that assembly got loaded, and you do reflection and triggering JIT compilation and get function pointer method and overwrite the native assembly code to install hook. So I recommend this way because it is easier for playing around for research purpose. But it might not be so like production level thing because only one custom app domain manager can be registered. All right, so I explained how to install hook and how .NET Framework works. And I am going to explain how to use that technique to get actual profit, to gain actual visibility into PowerShell. So the very important thing to know that PowerShell language is implemented in a DLL named System Management Automation, and that is written in C#. So PowerShell language is ultimately a managed program. And PowerShell.exe, it's just a client program of the DLL, the System Management Automation DLL. I will call the DLL as SMA DLL. So PowerShell.exe is just a client. So the idea here is that we are going to modify the behavior of SMA DLL by installing Hook in that DLL. So by installing Hook on SMA DLL, you can do many things. For example, you can possibly implement AMSI equivalent feature for older version of Windows, or you can implement AMSI for older version of PowerShell engines. And you can make AMSI kind of bypass resilient, bypass proof, and also, if you want to have more visibility, you could install Hook onto commandlet, and you can see commandlet execution. And also, if you want to have more, for example, you can access to deobfuscated string by hooking method used to deobfuscate string in the PowerShell. So let me quickly explain how you could implement AMSI equivalent feature for older version of Windows that runs PowerShell version 5. So for example, Windows 7 and PowerShell version 5 in that kind of situation. So in PowerShell version 5, invocation to AMSI providers are implemented in a method named scan content. So the signature of this content is in a slide. So it takes two parameters. First one is content. The content takes a string. Content is actual script content, script or command that is about to be executed by PowerShell engine. And the source metadata, this is a path to a script file if the content is backed by a file. Otherwise, it's empty. And important thing to take a look at is there's an if statement which checks whether AMSI init failed is true or not. And on older version of Windows, this AMSI init failed is going to be always true because there is no AMSI, DLL, AMSI infrastructure on older version of Windows. So initialization of AMSI fails, and this is going to be false, true. And if that is true, this scan content method doesn't do anything, just return immediately. The idea here is that we are going to overwrite this method and do your own scan instead of checking AMSI status. So you have a content and metadata. So using those two parameters, you scan maliciousness by yourself without calling AMSI. And you can do similar thing for older version of PowerShell engines, like PowerShell version 2, 3, 4. But there are some challenges. For example, there is no AMSI utils class, no scan content method. You can easily hook. And there is no open source implementation of the PowerShell engine. So PowerShell version 5 is already open sourced, so you can quite easily look up what method does what with comment. So for that reason, you have to do reverse engineer system management automation DLL in order to find method to hook to get information necessary to detect maliciousness. But there are some good news. There are some good open source, well, free .NET decompilers, and they produce very, very readable code compared with C++ decompiler. So it's quite actually easy to reverse engineer. And also, debugging is actually easier. So you have to learn a few commands to debug manager programs, but once you got used to it, it is easier to debug manager program than debugging C++ or C programs. And also, many implementation is still actually similar to the open source version of PowerShell. So you can kind of compare the result you see with a decompiler and maybe search some function name on GitHub against the open source version of PowerShell. And you can sometimes see very similar implementation with the same method. And that approach, so installing Hook onto SMA DLL, comes with a bonus that it automatically becomes a AMSI bypass resilient. Because we are not going to ask AMSI to scan the content, we are going to do this by myself. So it does not matter how AMSI, it doesn't matter how AMSI is working, whether it is okay or it's killed, it doesn't matter. You can still see the content in your code. So you can still scan the content and detect maliciousness. And the other idea, so apart from emulating AMSI, you can possibly hook commandlet, PowerShell commandlet. So PowerShell commandlet, each PowerShell commandlet is implemented in individual .NET classes. So for example, invoke expression commandlet is implemented in invoke expression command class. And when that commandlet, so for example, invoke expression commandlet is executed, then the process record method gets executed. So if you install your hook onto process record method, then you can get an access to all parameters via this pointer. So there's a small example in the slide. So the first line executing invoke expression with obfuscated string. And when you install a hook on process record method of invoke expression class, then when that method is invoked and your hooking code is executed, you can access to the deobfuscated version of string, any kinds of like final version of parameter via this pointer. So this is also a pretty powerful tool to get visibility into PowerShell activities. All right, so it's a demo time. So I am going to demonstrate AMSI a little bit, and then I'm going to demonstrate emulation version of AMSI. So in this system, so Windows 10 system, PowerShell, AMSI is already installed. So if you start PowerShell and do something, say hello code blue. So you see the output. So it's like in the PowerShell, there is an AMSI provider, and that is receiving the command being executed. And that AMSI provider is printing out what it received onto this upper window. So if you run code blue down, it shows code blue bang over there. And if you take a look at the loaded DLL, so there is a simple AMSI provider.dll. So this is your AMSI provider code. It's loaded by PowerShell and does a scan. So this is regular standard AMSI. So now I am going to install our hooking-based AMSI. So setting an environment variable because it is using an app domain manager. And start PowerShell. So if you execute some commands, so from here, you can tell output from AMSI provider. And here, you can see output from our hook-based AMSI provider. I would call it emulator or emulated version of AMSI. So it sees the same content. And let's try what happens when an attacker tries to disable AMSI. So this little command, this command basically disables AMSI from PowerShell. So if you execute this command, you see output from both sides. So from emulator, you see the executed command, and from AMSI, you can see the same output like this. But as you might have guessed, if you run further command, AMSI provider does not get anything. But your AMSI emulator still gets the content because your hook-based AMSI is not dependent on AMSI. So that's one nice thing of this technique. And I'm going to switch to a different implementation to demonstrate commandlet hook. So by the way, the first implementation I demonstrated doesn't only works for PowerShell version 5 because it is implemented by hooking scan content method, which is available only on PowerShell version 5. But the next thing, next implementation I am going to demo supports all versions of PowerShell because commandlet hooking is applicable for all versions of PowerShell. So this lovely command taken from recent server ransomware. So this command attempts to do something with PowerShell version 2 in order to bypass AMSI. And if you run this command, so here we don't see anything because it is executed by AMSI, well, PowerShell version 2, which does not support AMSI. But here, in our implementation, hook-based implementation, we see that it attempted to execute invoke expression with this command, like set execution policy and doing download a file from here and saving to temp folder and executing it. So it's pretty strong indicator of downloader behavior. So you can get this kind of visibility by doing commandlet hook. And last thing to demonstrate is string deobfuscation. I am going to switch to a different implementation. And going to run this also lovely commands, which is taken from recent malicious Office macro, which uses DDE command execution. So that, guys, the nice command tries to do something. And if you run this command and see output from AMSI, you might expect that AMSI gives something better, but it doesn't, because AMSI doesn't do any string deobfuscation. It sometimes works as if it does deobfuscation, but it doesn't. So what you can get is basically the same. Only the same thing you can see with AMSI provider. But if you install a hook in a method that is used to deobfuscate a string, in this case, a format operator. So if we hooked an implementation of the format operator, you see some nice, interesting output, like new object, net client, download string, some weird URL. So you can get this kind of visibility by implementing your own additional visibility logic using hooking technique. All right. So let me wrap up my talk. So this technique comes with some limitation. So because of the nature of hooking, first you have to do some reverse engineering to find appropriate method to install hooks. And you might need implementation-dependent code, because sometimes method you want to hook is not documented. So you kind of have to depending on current implementation rather than documentation. And also, if you hook lower layer of function method, it can be noisy because it can be called very, very often. So you have to pick exactly what you want to see rather than hooking everything. And also, attacker could use the same technique via PowerShell. So those commands kind of emulate what I did on C#, like getting. So this, I think this command basically overrides one method in the PowerShell, which invokes AMSI by overriding assembly code. So attacker could do the same thing with this technique for malicious purposes. All right, so let me wrap up my talk. So some takeaways from my talk. I think I am still going to emphasize the importance of AMSI. So AMSI still significantly increases visibility into script execution. So I would recommend you to what it does and understand what kind of benefit it might provide to your organizations. But it comes with some limitations. So if the limitation is critical, then you could employ this native code hooking technique to overcome the limitation of AMSI. And with this technique, you can implement AMSI equivalent feature, or you can implement more extended feature apart from what AMSI does. And I kind of compiled some recommendations for IT security professionals. So those are things I learned during my research, not quite specific to my talk, but so please consider using PowerShell Windows version 10 and PowerShell version 5, because it comes with a lot of nice security improvement. And also, when possible, consider using the constrained language mode of PowerShell with app blocker or device guard. It kills the vast majority, I think all, of AMSI bypass technique. And also remove PowerShell version 2, because if you left it, you're kind of leaving the way to work around bypass or security features provided by PowerShell version 5. And of course, keep system up to date. So the fix in AMSI side, I a little bit mentioned, is coming this winter. So Microsoft is fixing the flaw. And for security researchers, hunters, and for security software vendors, I recommend you to understand what AMSI does. So AMSI is still, well, it's still evolving. It's live and easily supported. So it's worth spending some time to understand what it does. And if it doesn't suffice your goals, please take a look at the .NET native code hooking technique for your goals, if it helps you or not. So that technique is pretty clean, so not much hackiness. So it is pretty realistic to apply that technique for your research tool or your product maybe. So if you are interested in this technique, then take a look at the GitHub page. The sample code should already be available. So you can play with this and ask me questions. And last thing, I guess, maybe pay attention to appearance of get function pointer method within the context of PowerShell. So if an attacker tries to employ the same technique, this technique, in malicious context, you probably see this method in the PowerShell. All right, the last but not least, thanks for Alex Inescu and Alan Lemasters, who helped me research this topic in many aspects. And also thanks for like big researchers, Matt Graber, especially Matt Graber and Daniel Bohannon, who repeatedly posted awesome research and tweets online. So I wouldn't be that interested in PowerShell field if they did not publish their really awesome work. Yeah, that is all I have. Thanks so much.